Hello, my name is Steve Miller. I'm a math professor at Williams College, and this is the last of the lectures on applications of the quadratic formula and quadratic equations. It's a pleasure to thank the Journal of Number Theory and the teachers of Scholars programs. Today we're going to talk about a fun and interesting application of parabolas to codes. So when you hear codes, what do you think of? Yeah.
Like for secret codes?
So you think of secret codes. So you think of trying to keep information secret. We're going to talk about, as illustrated in the bottom left, launch codes. So for instance, imagine we have a nuclear arsenal. For the record, I do not. Of course, if I had one, I might not admit it. And we are going to talk about how you can assign information so that only certain people can launch the nuclear weapons. Because it would be horrible if anybody could just launch the nuclear weapons. If you want to see a nice application of this, you can watch the movie Dr. Strangelove. There's a beautiful scene when a nuclear attack is being launched on Russia, and the president goes to the general and says, I thought I was the only one who had the authority to launch nuclear weapons. And the general responds, yes, Mr. President, that is true. I don't want to speak before all the facts are in, but it seems as if General Turgidson has exceeded his authority. All right, so here is the problem. So consider an army with 10 generals. We want a security system so that any 3 of them are able to launch the missiles, but no 2 of them can. So you need 3 generals to agree to launch. It is possible to devise such a system by using a quadratic polynomial. And that's why we're doing this as part of our lectures on applications of parabolas. So a quadratic polynomial would be something of ax squared plus bx plus c. So a, b, and c could be different numbers, maybe 3x squared plus 17x minus 4. And so if you want to launch the missiles, you have to input a, b, and c. And so the question is, how do we provide information? Is it possible to tell one of the generals all of A, B, and C? Would that satisfy the requirement we want?
No.
No, why not?
Because then they would be able to launch.
Yeah, then he or she could launch nuclear weapons by themselves. So you can't give one general 3 pieces of information. You can't give them A, B, and C.
You can't give them.
What if we gave them 2 pieces? What if we gave one of the generals, say, A and B?
Well, then if we gave whoever got C.
Good, and somebody has to have C then, right?
Yeah.
So you can't give somebody 2 pieces of information.
Actually, you could give everybody but one person the 2 pieces of information.
Well, but the thing is, any 3 people have to be able to launch. Any 3 people. What if you give everybody just an A, B, or a C? So maybe you get A, I get B, you get C. So if everybody gets just 1 piece of information, then what happens if a 4th person comes down? What do they get?
A.
Well, if they get an A, then if they and your A and my B won't work. If they get a B, then me, them, and my system to the right, it would be BBC wouldn't work.
Yeah. And it wouldn't work.
And it wouldn't work if it's a C. So we can't give people 3 pieces of A, B, and C. We can't give them 2 pieces of A, B, and C. And we can't give them 1 of A, B, and C. So it seems like there is no way to do this. So here is the riddle for you, and I'll pause in a moment. What information should we give the generals so that any 3 of them can find A, B, and C, but no 2 of them can? More generally, what if we have n generals and we want any m of them to be able to launch, but no set of m minus 1 can? So again, maybe we don't give them A, B, and C. Maybe we give them something else, and they can team up and figure it out. So I'm going to pause and let you think. All right, we are back. And so the solution is to use points on curves. So what we're going to do now is, at first, as I wrote over here, it seems hard to do. So a good advice in math is whenever you have a hard problem, try doing something simpler first. So let's imagine that there are only 3 generals, and we want any 2 of them to be able to launch missiles. And instead of using a parabola, let's try to use a line, ax plus b. And we can go through the same argument as before, and if we try to give each of our generals 1 of the numbers a, b, or c, we're going to run into the same problem as before. So again, if we gave each of our generals either a or b, then we run into the same problem as before, that 2 of them would have to have a, or 2 of them would have to have b. Similarly, if we gave somebody A and B, then they could just launch by themselves. So the dilemma suggests we think of another way of determining the equation of a line. And one of the nice things is, how many points determine a line?
2.
2 points. So maybe we give the generals information so that any two of them can figure out the equation of the line. So if we give each of the generals a point on the line, then any two of them can determine the line. So for example, imagine we have the line y equals ax plus b. We don't know what a and b are, and we tell one general the point 1, 1, and another general we tell the point 2, 3. Well, because they were on the line, 3 has to equal a times 2 plus b, and 1 has to equal a times 1 plus b. So you get 3 is 2a plus b, 1 is a plus b. So there's a couple of ways we could solve for this. One way is if we just subtract the second from the first, the b's cancel, and we would get 2 equals a, which is really nice. And once we know that a equals 2, if 1 equals 2 plus b, what does b equal?
-1.
-1, and we're done. Another thing we could do is you can say, well, if 1 equals a plus b, we can solve for b. b is just going to be 1 minus a. We substitute that into the first equation, we get 3 is 2a plus 1 minus a, or 3 is a plus 1, and not surprisingly, we get the same answer as before, a equals 2. So if we can solve systems of equations, which we know how to do, we can actually determine the a and the b. So if we continue, the same thing applies for the case with the generals. So now, imagine that 3 of the generals, one has the point mn, another one has rs, another one has ub. And then we can just plug them in to our system. So our polynomial is ax squared plus bx plus c. If we take x equals m and y equals n, we would get am squared plus bm plus c equals n. And I put the unknowns a, b, and c in red to remind us. So this is one equation. Now we plug in x equals r and y equals s, and we get our second equation, ar squared plus br plus c equals s. Then we get our third, au squared plus bu plus c equals v. So we have 3 equations and 3 unknowns. And so what we can do is we can solve for a, b, and c, and it works. What's nice about this is you can generalize. So imagine instead of you need 3 generals, imagine you need 8 generals. Could you still do that with a parabola?
Yeah. No.
Or would you need something higher?
You need something higher.
Yeah.
Because like a parabola, you only need.
So parabola is degree 2, and we needed 3 people.
I'd say degree 7.
So if we want to have 8 people,
Degree 7.
it would be degree 7. Now here's something that you could do that's, and you can even do this with the parabola. Maybe some people are more important than others. So maybe you could give them 2 points. So maybe you need 10 people to launch. The president gets 10 points. The vice president gets 8. Well, the president could launch by themselves. The vice president gets 8. Maybe one of the generals gets 7. And then what you could even do is you might say that, well, these 2 people are in different people, but they're really very closely related. Maybe I'll give them some points in common. So that you have
give
to
them the same points.
You could even give some people the same points, so that you need 3 people, but one of them can't be your spouse. You could do stuff like that. And so how would we find the parabola? Well, a quadratic equation or a parabola is ax squared plus bx plus c. So imagine we know the points 0, 7, 1, 5, and 2, 9. So this is the slide we've seen several times before. If y equals 7 and x is 0, we get 7 is a 0 squared plus b times 0 plus c. So that's very nice if the point is 0, and we get 7 equals c. The point 1 isn't too bad. Instead of the point 2, 9, what would you rather have rather than a 2? What number would you rather have there? Not 3. No, -1. You want to keep the x's as low as possible to keep the numbers. It doesn't really matter.
But you could do it with 55.
You could do it with 55. It's
It'd just be like really annoying.
Exactly. Just try to keep things simple. And so we can go through and we find at the end of the day that a equals 3, b equals -5, and c equals 7. So those 3 points are enough to uniquely determine the parabola.
Then once you figure it out, then you can just launch.
Yes, but I mean, hopefully you only have to figure it out once. So the last thing is, to generalize, as we talked about, you could look at a polynomial of higher degree. And so what I love about this problem is it's another nice example of the stuff we're doing with quadratics, with parabolas. It is another nice example of solving systems of equations. as to why we might want to do this. And it's also of looking at things in a slightly different way. So before, we were trying to think of giving generals information like A, B, or C, the things we want, the triple, because it's A, B, C that launches. And instead, we realized, we don't have to do that. We can give them information that they then use to compute A, B, and C. And in a later lecture, we might talk about how this is done for streaming video or sending information. With most of us now staying home because of the coronavirus, a lot of us are watching a lot more streaming video than we used to. How does it work? If you had to send every bit, every pixel of an image, that'd be a lot of information to send. So how can you send just a few pieces of information and have your system assemble the video on the other end? Well, the important thing to note is you have smart computers on both ends. And so it can reproduce, or smartphones, and it can reproduce the stuff. So I hope you enjoyed today's lecture. Be sensible, have a great day, take care.